Good evening. Sum number 15 from exercise 4.1. Given that Tn plus 1 equal to 5Tn plus 4, T1 equal to 4, prove by method of induction that Tn equal to 5 raised to n minus 1. Let Pn be the given statement that Tn is 5 raised to n minus 1, where Tn plus 1 equal to 5Tn plus 4 and T1 equal to 4. Now for n equal to 1, what is LHS? T1, that is first term, which is 4. What is RHS? 5 raised to 1, that is 5 minus 1 equal to 4. Therefore, LHS equal to RHS. Means what? P of 1 is nothing but 2. Now in the second step, we assume that for some k belonging to set of natural numbers, P of k is true. Means what? Tk is nothing but 5 raised to k minus 1. Suppose this is result number 1. Now in the step 3, we prove that P of k plus 1 is true. That is to prove that Tk plus 1 equal to 5 into T raised to k plus 1 minus 1. We begin with LHS. Tk plus 1 is 5Tk plus 4. Reason? Tn plus 1 is given to be this. Variable is immaterial because n is natural number. So is k. Now what is Tk? It is 5 raised to k minus 1. Substitute. Open the bracket. 5 into 5 raised to k as per laws of indices is 5 raised to k plus 1. What is minus 5 plus 1? It is minus 1. Now this is nothing but right hand side. So P of k plus 1 is true. Usually we say this implies, or P of k is true implies P of k plus 1 is true. And in the last step we say that from all the above steps and by the principle of mathematical induction, P of n is true for all n belonging to capital N. For convenience, we have denoted or we have used Pn. So you have to say that is Tn is 5 raised to n minus 1 for all n belonging to set of natural numbers, where Tn plus 1 is 5Tn plus 4 and T1 is nothing but 4. Now the next one. The last one from this exercise, prove by method of induction that nth power of matrix 1, 2, 0, 1 equal to which matrix? 1, 2, and 0, 1, where n is a natural number. Right on. We begin with let Pn be the given statement. Right on. Step 1. Or n equal to 1. What is LHS? 1, 2, 0, 1 raised to 1. This is RHS. Therefore, P of 1 is true as LHS equal to RHS. Right now. So in the second step, we assume that P of k is true. That is kth power of matrix 1, 2, 0, 1 is which matrix? 1, 2k, 0, 1, where k is a natural number. In the step 3, we prove that P of k plus 1 is true. That is to prove k plus first power of matrix 1, 2, 0, 1 is which matrix? 1, 2 into in bracket k plus 1, 0, 1. That is matrix 1, 2k plus 2, 0, 1. Now begin with LHS. Now raised to k plus 1 means raised to k into that matrix. But for this matrix, see the cursor. For this matrix, we can replace we can write what? Matrix 1, 2k, 0, 1. Reason from 1. Now take the product of these two matrices. So matrix 1, 2k, 0, 1 multiplied by which matrix? 1, 2, 0, 1. Matrix product is row by column product. So first row, first column, 1, 1, 1 plus 2k into 0, that is 0. 1 into 2, 2. 2k into 1, 2k. So 2 plus 2k. Then second row, first column, 0, 1, 0, 1, 0, 0. Second row, second column, 0, 2, 0, 1, 1, 1. So which matrix? 1, 2k plus 2, 0, 1. This is RHS. Therefore, P of k plus 1 is true. That is, P of k is true implies P of k plus 1 is true. So in the step 4 way to say from above steps and by, actually I should have written by the principle of mathematical induction. Principally we should add the word principle of mathematical induction. P of n is true for all n belonging to capital N. That is, nth power of matrix 1, 2, 0, 1 is which matrix? 1, 2n, 0, 1, where n is a natural number. Now we discuss binomial theorem. In the first part, we discuss binomial theorem for positive integral indices only. And then we consider binomial theorem for any real index. Now what is binomial? Binomial means an expression containing two terms. If A and B are real numbers, then A plus B is a binomial. Now we are interested in finding the expansion of A plus B raised to n, where n is a natural number. Now let us observe the following pattern and we'll try to guess the expansion of A plus B raised to n. What is A plus B raised to 1? It is obviously A plus B. Now can I write A plus B as 1 C0 A raised to 1 plus 1 C1 B raised to 1. What I have written is correct because 1 C0 is 1. Yes, coefficient of A is 1 only. Can I write A as A raised to 1? Yes, I can. Similarly, 1 C1 is also 1. Okay. Now, what is A plus B square? A plus B square is A square plus twice AB plus B square. Here index is 2. Now, coefficient of A square, see the cursor, coefficient of A square is 1. But I will write that as 2C0. So 2C0 A square. Now coefficient of AB is 2. So I write it as 2C1. I hope you remember formula for NCR plus 1B square. I write it as 2C2. Is 2C2 1? Yes. Okay. Now, what is A plus B bracket cube? A plus B bracket cube is A cube plus thrice A square B plus thrice AB square plus B cube. Now index is 3. So I write this as 3C0 A cube plus 3C1 A square B plus 3C2 AB square and finally 3C3 B cube. Okay. Now what is A plus B raised to 4? You may say A plus B raised to 4 is A plus B square, which is A square plus 2AB plus B square. Square that. Now A plus B raised to 4, if you expand using this method, then it is A raised to 4 plus 4 A cube B plus 6 A square B square plus 4ab cube plus b raised to 4. Now, I will say coefficient of a raised to 4, which is 1. 4c0. Is 4c0 1? Yes, it is. A raised to 4. Plus 4c1 a cube b plus 4c2 a square b square plus 4c3. What is 4c3? It is 4c1, that is 4. Yes, coefficient of ab square. In fact, ab cube, not ab square, is what? It is 4 only. Plus 1b raised to 4. I will write it as 4c4 b raised to 4. I hope that this pattern is suggesting something which helps us to guess the expansion of a plus b raised to n. Of course, this can be proved using method of induction. Now, who will guess this expansion? Who will tell me right hand side? That is expansion of a plus b raised to n. Try. Now tell me expansion of a plus b raised to n.
nc0 a raised to n b raised to 0 plus nc1 a raised to n minus 1 b raised to 1 plus nc2 a raised to n minus 2 b raised to 2 and so on up till ncn a raised to 0 b raised to n.
Very good. Actually, you need not say b raised to 0 in the first case and a raised to 0 in the last case, but that is not wrong. Actually, what makes us to write this expansion, I'll tell you. See, index is 3. We begin with 3c0 and end with 3c3. Index is 4. We begin with 4c0 and end with 4c4. Few more observations. Index is 4. So the first term is a raised to 4. Index of a goes on decreasing by 1. See, 4, 3, 2, 1, and there is no terming a in the last one. Actually, it is a raised to 0, I can say, because a raised to 0 is 1. At the same time, index of b goes on increasing by 1. Sum of the indices of a and b in each term is the index of binomial. 4, 3 plus 1, 4, 2 plus 2, 4, and so on. And therefore, we can guess expansion of a plus b raised to n as what? nc0 a raised to n plus nc1, index of a decreases by 1, and at the same time index of a or rather b increases by 1, plus nc2 a raised to n minus 2b square plus nc3 a raised to n minus 3 into b cube, and so on. Up to what? Up to, I can say, ncn b raised to n. Now, this is nothing but binomial theorem and can be proved using method of induction. See, just a minute. Yes. So, just go through this. We'll discuss the proof in the next lecture. Same method. We denote the result by P of n and so on. Okay. Now, I have already told you the important features of this. What will be expansion of a minus b raised to n? Can you tell me? Basically, what is a minus b? It is interesting. What is a minus b? It is a plus minus b. I hope you are getting this. So this is nc0 a raised to n plus nc1 a raised to n, rather a raised to n minus 1. Just a minute. I hope I have written this correctly. Let me check. Yes, I have. Okay. So a raised to n minus 1 into minus b. Okay. Plus nc2 a raised to n minus 2 into minus b square and so on up to ncn minus b raised to n. Right. Now nc0 a raised to n as it is into minus b. So second term becomes negative. So nc1 a raised to n minus 1 into b plus third term will be positive. Why? Because square of minus b is again plus b square. So plus nc2 a raised to n minus 2 into b square. Obviously next term will be negative. It will be nc3 a raised to n minus 3 into b and so on. Now I cannot decide the sign of last term because I do not know value of n. So I'll just write ncn minus b raised to n. Is that clear? I'll repeat remaining observations. They are important. One more observation. See, if index is 4, there are how many terms in the expansion? 1, 2, 3, 4, 5. So another important observation is number of terms is 1 more than the index. Index is n. So there are how many? N plus 1 terms in the expansion of a plus b raised to n, where n is a natural number. Now remaining observations that sum of the indices of a and b in each term is the same, and it is nothing but index of this binomial. See, n minus 2 plus 2 is n, n minus 3 plus 3 is n, and so on. Index of a decreases by 1, and at the same time index of a increases by 1. Another interesting observation, binomial coefficients repeat in reverse order. Means what? First binomial coefficient is nc0, last one is ncn. Are they equal? Yes. Second binomial coefficient is nc1, which is the last but one, ncn minus 1. Note that nc1 is the same as ncn minus 1. You can see this. See, 1, 1, 4, 4. So binomial coefficients, they repeat in the reverse order. Write down this binomial theorem. This is the statement. Initially, we consider index as natural, and then we consider any real index. So in the first note, we say that in the expansion of a minus b raised to n, terms are alternately positive and negative. Write down. Write down second point. There are n plus 1 terms. There are n plus 1 terms in the expansion. There are n plus 1 terms in the expansion. That is number of terms is 1 more. That is number of terms is 1 more than the index. Third point, index of a, because we are considering a plus b raised to n, that is why I am saying a, otherwise first term. Index of a goes on decreasing by 1. Index of a, small a, goes on decreasing by 1. And at the same time, index of b increases by 1. Index of b increases by 1. Full stop. Sum of the SUM sum of the indices of A and B, sum of the indices of A and B in each term is n. In each term is n. Next point. Binomial coefficients repeat. Now what are binomial coefficients? NC0, NC1, NCn. They are binomial coefficients. Write down. Binomial coefficients repeat in the reverse order. Binomial coefficients repeat in the reverse order. Okay. Now, exercise 4.2. We are asked to expand. We are asked to find expansion of what? Write down. Root 3 plus root 2 raised to 4. So start writing. As per binomial theorem, this is 4C0. Don't omit steps. Root 3 raised to 4 plus 4C1 root 3 cube into root 2. This is not at all difficult. Plus 4C2 root 3 square root 2 square plus 4C3 root 3 root 2 cube plus 4C4 root 2 raised to 4. Now the next job is to find values of binomial coefficients. Let me explain. 4C0 is 4C4. Actually, after sufficient practice, you can drop this first and last because it is going to be 1 only. So this is 1. Then what is 4C1? It is same as 4C3, complementary combinations, which is nothing but 4. And last one will be 4C2. 4 factorial upon 2 factorial into 2 factorial. 4 factorial is 24 upon 4. So this is nothing but 6. Now substitute the values and simplify. So what is root 3 plus root 2 raised to 4? 9 plus 4, 3 root 3 into root 2 plus 6 into 3. Why 3? Because root 3 square is 3. Root 2 square is 2 plus 4 root 3. What is cube of root 2? 2 root 2 plus what is root 2 raised to 4? 4. So on simplification, you get 9 plus 12 root 6 plus 36 plus 8 root 6 plus 4. Finally, it is 49 plus 20 root 6. Second, root 5 minus root 2 raised to 5. Actually, it should say by binomial theorem, this equals 5C0 root 5 raised to 5 minus 5C1. Index of first decreases by 1. Index of second at the same time increases by 1. Terms are alternately positive and negative. So minus 5C1 root 5 raised to 4 into root 2 plus 5C2 root 5 cube into root 2 square minus 5C3 root 5 square into root 2 cube plus 5C4 root 5 into root 2 raised to 4 minus 5C5 root 2 raised to 5. Next job is to obtain binomial coefficients. 5C0 is same as 5C5. After sufficient practice, you can drop this and directly say 1 into nth power of first term and so on. Now it is 5 root 5 raised to 5. It is 25 root 5. Check this. So this is 25 root 5 minus 125 root 2, is it? Plus 100 root 5, then minus 100 root 2, okay, minus 100 root 2 plus 20 root 5, and which is the last term, it is minus 4 root 2. Okay, now tell me what is the final answer. So it is root 5 minus root 2 raised to 5. I think this is collect terms in root 5. So 25 plus 100 plus 20. So 145 root 5. Please check this. Then terms in root 2 with negative sign, of course. 125 plus 100 plus 4. Minus 229 root 2. So this is the expansion. Second, first part is for homework. First is expansion of what? 2x square plus 3 raised to 4. I repeat, fourth power of 2x square plus 3. And answer should be 16x raised to 8 plus 96x raised to 6 plus 216x raised to 4 plus 216x square plus 81. Next, for classwork, sixth power of 2x minus 1 upon x. So using binomial theorem, 6c0, 2x raised to 6 minus 6c1, 2x raised to 5 into 1 upon x. See, many students write minus 1 upon x here. Please don't do that. That sign we have already taken into consideration. Otherwise, it will be minus minus plus. Terms are alternately positive and negative. Okay. So plus 6c2, 2x raised to 4, square of 1 upon x, and so on. Now next job is to find binomial coefficients. Tell me binomial coefficients. So these are the values of binomial coefficients. So what is 2x minus 1 upon x raised to 6? 64x raised to 6 minus 6 into 32x raised to 5 into 1 upon x plus 15 into 16x raised to 4 into 1 upon x square minus 20 into 8x cube into 1 upon x cube plus 15 4x square into 1 upon x raised to 4 minus 6 into 2x into 1 upon x raised to 5 plus 1 upon x raised to 6. Now tell me what will be the final answer. It will be 64x raised to 6 minus 192x raised to 4, okay, plus it will be 240, is it? 240x square minus 160 constant term. Yes. Plus 60 upon x square minus 12 upon x raised to 4 plus 1 upon x raised to 6. This is the final answer. So that's it for today.